know.
Okay, yeah, we can begin now.
Okay. All right. Okay, so today I'll be talking about extended reality. Before I begin, maybe just a quick introduction of myself. So my name is Kawe. I'm currently technical lead at Hello Holo, and Hello Holo basically is a development agency developing extended reality applications, right, ranging from VR, MR, and AR. If you're not familiar with what those are, I'll go into those in a bit. But yeah, right. So a little bit more about how I came to where I am today. Back in 2016, when I was still in NYP game dev, right? I started Hello Holo with two other friends, and from then it developed over the course of what has been, wow, it's been 6 years now,
Okay,
right?
yeah, I also feel
So,
like
oops, yeah, okay, sorry. Yeah, so since then I graduated, I went NS, and after I came out, I was full-time technical lead at Hello Holo, and after that, a year of like full timing there, I'm now in DigiPen studying real-time interactive simulations. So a couple of my interests are game engine architecture, tools design, XR, of course, since I was working in this field, right, and still am. UX design, game-based systems, and I love cats, right? Mostly I'm focused on C++, C Sharp, .NET, and graphics. And for what you'll be seeing, I'll be talking about a lot of it relates to Unity because that's the most common engine we'll be using to develop XR applications. Right. So while I was at Hello Holo, one of my main responsibilities was building our internal XR framework. So this XR framework allows us to easily create applications for VR, AR on mobile, as well as dedicated XR devices, right? Which I'll talk about later on. And this works cross-platform, write once, run and everywhere, right? I also work on client projects and taught classes on XR development at SIT. So on to the meat of it. What is extended reality, right? The term XR is used a lot. Sometimes it's also known as cross reality because of the X and all that. But the idea behind it is that it encompasses the entire spectrum of all these kind of realities. First, I think most of people should be quite familiar with what VR is, right? You put on a VR headset, you're immersed in a brand new world. You can use motion controls to interact with. There's use cases ranging from games to simple like industrial use cases where they do training, or even things like trying to bring you to a new world just to experience like maybe how it's like in another country and so on. Then we have AR, which is in quite an interesting position right now, because if you think about it from say 10 years ago, when you think about AR, you're thinking about, oh, you take out your phone or some camera and you look at this barcode or QR code, and then something will appear out of there. And there's not much interactivity. Yes, it gives you like sort of a 3D perspective on certain objects, but that's pretty much about it. So AR now, however, has gone a bit more than that, right? And I'll talk a bit more about it as I go into AR a bit further. But then we also have mixed reality. And in a way, mixed reality, you can sort of see it being the in-between. It brings the best of both the VR and AR worlds. So in VR, one of the key things that makes VR interesting is not just the fact that you're putting the VR headset on your head and you're able to see everything around you in that is part of a different world, but also you're able to interact with it. And in general, MR allows you to interact with objects in a very similar way, be it with controllers or with your hands. And we'll see a couple of devices later on that allows you to do just that. The other thing about MR that AR is actually slowly encroaching into is that MR has knowledge of your space, right? It's able to know that, oh, there's a table here, there's a wall here. And based on that, right, it's able to construct a 3D mesh of your surroundings and work with that. Okay, one key thing that I think a lot of people are a bit confused between what MR and AR is, right, is that MR tends to be built as a headset. AR usually you can bring out your phone. Yes, there are AR glasses and so on, but generally with MR, right, you have a headset that has a see-through display. So you're seeing the real world and the digital objects with your eyes. You're not looking at it through a different display, and this adds a very, very different effect to how you interact with the world and how natural everything feels. All right, so we're going to go through the different kind of considerations, right, across different types of devices. It's entirely possible for you to build an application that works in VR, AR, and MR at the same time. But how you adapt your application to it, or how you specialize your application to work better in specific types of realities matters. The first thing to consider is, of course, the hardware, right? Hardware, the type of duration, etc. All of these different properties. I'll go into each of them one by one. Now, first thing is hardware limitations. This isn't just the hardware specifications, but it also comes with things like how much the device costs. When the HoloLens 1 came out in 2016, right, it cost about 3,000 USD. The fact that the price is so high, right, means that the average person, me, you, etc., your parents living at home, your friends, they can't really get this device. And that affects the type of experience they can deliver and the type of target audience you're targeting. So when you're creating an XR experience, you need to take that into consideration. Things like battery life also matters, right? Generally, if you have a mobile device like this, right, versus a PC VR headset that's tied to your PC, of course, with the PC headset, you don't have to worry about battery life. And all of these affect, right? Things like temperature, weight, and so on. Temperature is interesting because for certain devices, like the original HoloLens, we actually brought it out to Clarke Quay once to try to do a demo there. It would shut down in about 10 to 15 minutes because it was too hot during the evening. So that's something to consider. You need to test these devices out. The other thing is weight and design. The weight and design matters a lot because, for example, right, the HoloLens here, if I recall, was somewhere around 500 grams. That seems like quite a lot to put on your head, and it is. But the HoloLens 2 which came out right after was only about, I think, 20 grams lighter. But because the design changed, right, it affected the entire comfort of the device. So a lot of things aren't just simple numbers you can see on your spec sheet. You need to actually try them out, and it makes quite a big difference. Right, yeah. So duration and comfort. Why does this matter? One of the key things that's actually stopping people from getting to VR, especially people who haven't played with games, right? A lot of times companies are like, okay, let's try using VR to do training. But due to the nature of VR, right, and how your VR headset cannot replicate how your eye works 100%, it's very easy for certain people to get motion sickness. The technology is improving, of course, but until we get to the point where it is perfect for most people, you're gonna have to deal with the fact that not everyone will be able to use the headset in the way that you expect them to. So some people might be able to last like a couple of minutes. Other people can just put it on and work with it the whole day. So these are things you need to keep in mind when designing the experiences. Yeah, I think with collaboration. Now, the thing about XR experiences, right, is that on its own, right, the fact that you're using XR, be it VR, AR, MR, there's already a certain amount of novelty to it that makes it very interesting for people, even if the actual experience itself isn't too interesting. The fact that it is novel already helps garner a lot of attention. However, what makes things more interesting is if you're able to bring in multi-user experiences. So if I'm able to like play a game in XR, and my friend is able to be standing beside me and playing the same thing with me, right? It increases the immersion a lot. But think about it. We have expensive devices, we have cheaper devices. With the expensive devices like the HoloLens, where it costs about 3,000 USD per headset, right? It's not feasible to get everyone on it, right? Unless you're really a huge company and so on. So what's present, right, is that usually what we'll do, this is of course more for exhibitions, more for industrial applications and demonstrations. We would have something called a spectator view set up, where we'll open up a separate application. Nowadays, it's linked to the same application, but you can open up a separate 2D version of the application and allow other users to also view the same experience, even if they may not be able to put on the headset and participate directly. So depending on the type of use case, for example, if you're doing, let's say, a VR escape room. Something like this would be very, very good to put, like, for example, at the outside of your escape rooms, like at the counter or something, so that people who are waiting to go in, right, can be entertained by what other people are also experiencing before they get to their turn. And interactions. Now, interactions is very interesting, especially if you're building cross reality applications across different, because VR, AR, and MR. Because depending on the type of hardware, you have very different limitations in how you can interact. The newer devices have hand tracking. That means your users can go in and start touching objects, playing around with them. But what happens if you need to support older devices that do not have hand tracking? These are things you have to consider. And different devices, for example, if you're building for VR, the original HTC Vive has quite a heavy controller with touchpads and a trigger, right? But newer devices like the Oculus Quest, etc., they do not have a touchpad. How are you going to change your interactions and make it so that you are able to support a wide array of different controllers? Are you going to manually set it up for each of them, or are you going to go with a good enough setup that works across all devices? That is something you need to consider, and it's one of the key issues with developing for VR. You need to test with so many possible devices that, sometimes some companies just, what, screw it, we'll just support the main device. And then you're gonna see a lot of posts online about people like, hey, it doesn't really work well with this, doesn't work well with that, and then you get a bad review, etc. Right? If you look at some of it's not so much of a problem now, but if you look at certain VR games on Steam, you're gonna see a lot of these kind of reviews. Right. The other thing is related to controllers, right? This is not so much of a problem now, since most of the headsets nowadays, right, you can actually have position and rotational tracking for your controllers. So before that, this was during very early stage of VR. The original Oculus did not have rotational tracking. Did not have positional tracking, sorry. So you're able to move your head around, look around, but the moment you take one step forwards, right, your in-game camera doesn't move with you. And it can be very disorienting. These systems are great for example, if you're playing a flight simulator, or if you're playing a racing simulator, because generally you'll be sitting down in your pilot or driver seat, right? But as you move on to things like if you're creating a first-person shooter in VR, these becomes very big limitations. And especially as you move on to things like AR and MR, right, where the user is able to see their environment, it doesn't make sense if they move their device or move themselves, and what they're seeing is sort of stuck at some previous position. It becomes very disorienting. It feels like it completely ruins the immersion. And the other is physical spaces. Do you intend for this experience to be used sitting down, right? Standing within a small space or a large space? One of the key things that you'll need to do, right, when you set up for example, a Valve Index headset or a Vive headset or Quest or Oculus headset, etc., the first thing you need to do is you'll be requested to set up your play area. And this play area is entirely up to your user. It could be, I don't have enough space, so I'm just sitting down in front of my PC. Or I have like about a 5x5 meter space because I have a very big living room. These things affect how you design your application. And this information is provided to you as a developer. So based on that, you can actually adjust, should I make adjustments to how my interactions work? If the user is in a very cramped space, do I narrow down the kind of interactions to make it safer for the user, right? You don't want the user actually smash their monitor. It happens too often, right? If you go into Reddit, say virtual reality subreddit, you're gonna see a lot of these happening. Not so much nowadays, but it's still a concern. And your user will appreciate it if you take those into account. Right. The other thing is, if you're not designing an application that you sell on Steam and so on, right? If you are designing it for, let's say, an escape room, then you have to consider a lot more things, right? Is your virtual experience going to 100% match your physical space? Is there some sort of physical level that matches a virtual level that they have to interact with? All of these are things you need to take into account, and it can be very, very tedious to try and match and so on. And immersion. This is not so much of a problem for VR because VR does have very wide field of views compared to AR and MR. And we'll take a look at a comparison of different XR headsets with regards to the field of view. But all of these makes difference. For most of the MR devices, right, you'll realize that you'll be able to see sort of a window into a virtual world. Anything outside of that window, right, which is beyond the field of view, you'll see no digital content. So it can be quite disruptive if, let's say, you have a very big object and then your user looks at only one part of it. They're going to see that object get cut off at the sides, which can be problematic. One of the workarounds is simply to, if you are aware that your device that you're working with, right, and the users will be using has a narrow field of view, try not to make big objects, right? Especially so if they have to interact with the big object, because what's going to happen is they're going to look at the big object, but because the big object covers up the entire window into the virtual world, they get lost, right? Everywhere you look, you just see a part of the model which may have the same texture. It's very hard for your users to orient and figure out where they are. The other thing is interpupillary distance. This is so much for you as a developer who are designing and creating these applications. But if you're creating a custom solution for a client, right, the interpupillary distance is something you consider because what this interpupillary distance is, right, is the distance between your pupils. And each headset will have limitations on this. So for example, if I recall correctly, HTC Vive can support anywhere from, I think, 55 mm to about 70 or so mm. If you happen to have a user that has much narrower or wider, I kind of find it hard to believe that someone have greater than 70, but I guess these people do exist. They won't be able to use the device properly. Things may look out of place, things may look blurry. So if for whatever reason you need kids to work with this is something you need to consider. Right, the other thing is refresh rate. The higher refresh rate, the better, of course. The more immersive it is. But again, it depends on your hardware. Your hardware may not support that higher refresh rate.
Sorry, Kawa, if you don't mind, I got a question on this.
Yeah, sure.
Yeah, because if you use a headset, right, with a very high screen immersion and you need to move around, how are you going to ensure that you won't bump into something in real life?
Okay, so it depends between you're working with VR or AR MR. With AR MR, because you already are able to see the world around you, right? And generally those devices have narrower field of view. It's usually not that big of an issue. But yes, in VR, that sort of becomes a problem, right? You might knock into things around, which is why it's important that when your user sets up, right, they define an accurate bounding space which they can play in. And you as a developer can take that into account. You can show additional warnings if you realize they're getting too close to the boundaries. By default, if you're using Oculus, or actually most of the headsets, Oculus, Steam, even Windows headsets, they all do warn you when you're reaching the corners of the bounds. But again, the user can turn this off. And at the end of the day, as developers, we sort of need to accept that there's only so much we can do. If the user disables all of the warnings, then we're kind of out of luck there. But yes, do take into account if you within your application is able to detect that the user is reaching the corners, right? Or they, for example, in let's say a shooter, a lot of times people will be throwing grenades and things like that. It's very, very easy for them to just try to throw, right, something that's out of bounds and hit something. So these are considerations. Generally, as a developer, you should do it. The system usually provides enough leeway, but yeah, more protection against that can't hurt.
All right, thank you.
Yeah, no problem. Okay, so the other thing is tracking, and tracking is something that is a bit, I think, misled by the way VR in general is covered. There are two key types of tracking, and they have different accuracies. The first is the much older system, but it's also definitely much more accurate. It's called an outside-in tracking. So how this works is that the user puts on their headset or their devices, etc., and you will have cameras mounted on the outside, right, surrounding them. And these cameras will identify the user based on where they are, and then translate that into the actual position and orientation inside your that's related to your application. The other one is inside out, where you have a camera or sensor on the device itself. And usually these use a combination of cameras, depth cameras, things like accelerometers, gyroscopes to figure out and calculate your user position in the world. Right now, just a question, because this is a very common mistake that I see. Does anyone guess if the Valve Index or the Vive, if you guys heard of those before, are they inside out or outside in track devices? No, no one has a guess. Well, a comment.
Never heard of it.
Oh, never heard of it. Okay, so later on I'll give. Okay, you know what? I'll hold this for now, and we'll come back to this later on once I touch onto those devices. It'll be clearer then. Okay, the other thing is sound. Generally, sound is something that is very important, but very easily neglected by people, especially when you're doing game development. In the grand scheme of things, people tend to focus a lot on graphics, game feel, and so on, with sound usually falling quite far behind, especially for smaller teams who do not have people dedicated to working on sound. But in VR, AR, MR, right, sound mix is even more important. It's not something that you can just leave out away. Like usually in your 2D games, right, and you usually like, okay, as long as sound is decent, it provides a good enough experience. But in VR, right, VR, MR, AR, you need to make sure that your sound effects are good enough so that they are immersive, right? Because for those of you who have played first-person shooters, you guys probably know that, inside a tense situation, I'll be able to hear someone walking from behind me. I know where they are and I can react accordingly. The same thing in VR, MR, AR, right? Because your user is effectively putting the headset on their head, right? They need to know what's behind them, what's around them, and so on. So spatial audio is very, very important. And especially on devices where using touch, using your hand control, using your hands as controllers and so on, right? You're required to touch objects. But touching objects has no feedback, right? In the real world, when you touch an object, you feel that your hand is in contact with the object. But in the virtual world, you sort of just press something in midair, and it doesn't feel great. So one of the key ways, right, to actually make touching objects feel tactile, even though you're not actually touching anything, is to use sound, right? The moment you touch something, it makes a sound, and you get that feedback to know that, hey, I actually pressed this. And if let's say you press something, right, nothing happens, right, you can at least tell that, oh, maybe I need to do something else. Otherwise, this object that I press isn't reacting. And if you don't have that audio, right, the user might be, okay, shit, did I actually press this? Did the game even recognize my hand? Is this a problem with the headset or my tracking system, etc.? So audio is very important. Yeah, I think it's animation. This again more important for MR and AR devices, especially when you're touching stuff. If you're touching stuff, you want it to animate to react, right? Otherwise, you get the same problem as what I just mentioned earlier. The other thing is because things are in their physical surroundings, right? In the real world, you don't usually see things appear and disappear. It's kind of very disruptive, right? In the real world, objects move around, they don't disappear out of nowhere. Physical objects occupy space and they move in a natural manner. So it's important that any transitions, any objects that you add into your player surroundings, right, need to animate in a smooth manner. All right, so we're going to take a quick look at some of the common devices that we see nowadays, right? For VR, yeah, pretty straightforward what I've just mentioned before. You do notice that I do have a point regarding its inconvenience. This is sort of a balance right now because you have headsets like the Oculus Quest, which I'll touch on a bit, which is fully wireless, and all the components, the processing power is all self-contained in the device itself, which means that you don't really have to do any setup. However, those have much weaker processors, of course. And if you want something that's much more powerful, right, of course, you need to connect it to a PC. You need to set up a lot of things. You may have to, in the case of the headset that you see here, right, this is the HTC Vive, the original one. And you'll see that there are these boxes that you have to put around your space. And these boxes are required to assist with tracking. And they have to be plugged to a power source. Usually you have about 2 of them. So you have to look, oh, I have to have I've plugged these into 2 different sockets. I need to make sure that wherever I'm placing them, and we usually place them far apart to get better coverage of your space, you make sure that those power sockets exist, and they are within view of the main headset. And the main headset needs to connect to the PC, etc. You need to turn on your PC, launch Steam, select your game, and get in. Whereas the newer mobile headsets don't require all of that inconvenience, right? So some of the headsets you see now, one of them is the HTC Vive Cosmos, right? And okay, I just revealed the answer to the question just now, but never mind. Okay, so this is a exclusive PC headset, meaning you can't use it on its own. You have to connect to a PC, and the tracking is unique in the sense that it supports 2 different types of tracking. Now, before that, what I mentioned was that tracking has 2 different versions: inside out and outside in. Outside in requires not 4, but multiple cameras surrounding you. And one misconception, right, is especially with this headset that I showed earlier with the base stations, the boxes they put around, people always assume that it is a outside in track system, because why else would you have to put boxes around your surroundings? However, these boxes are not cameras. In fact, they are sort of a infrared light projector. They project all of these lights around your room. And if you look at the main headset itself, right, you see that there are these bumps on it. These are actually IR sensors. And how the device works is that it receives these IR lasers, right? IR light lasers, I'm not sure that's the correct term, but it receives all of these IR from the base stations, and based on that calculates the position. So it's actually an inside out track device. However, what people commonly talk about, right, when they say inside outside in, right, is they're actually referring to whether you need to set up base stations or not. And with the Vive Cosmos, right, you actually have both systems. Yes, it's sort of like triangulation. Yeah. So with the Vive Cosmos, you actually have 2 ways of going about this. One, you can rely on the existing base stations, or 2, if you look at the picture of the device itself, right, it actually has 2 cameras on the front, 2 cameras on the sides, and 1 at the bottom and at the top. So these cameras actually make a map of their surroundings and help it figure out where it is in the world. So you do not have to set up additional boxes around your space. Now, of course, there are limitations. In general, base station solutions are much more accurate, right? Because triangulation is, of course, much more powerful than trying to detect your position based on the cameras alone, right? On top of that, we also have the Vive Pro 2i. This is unique in the sense that this actually has eye tracking, and eye tracking is an interesting concept because it allows you to understand where your user is looking and allow for additional interactions. Like, for example, if the user is looking at this specific object, perhaps if he pulls a trigger on the controller, he wants to do something with that object, right? Instead of without having this contextual information, the user has to manually point. And sometimes with the very nature of pointing with a controller, right, it's very easy to point wrongly. But if you're able to couple this together with eye tracking, right, you can know straight away the user is looking at this and pointing in this general direction. If he's looking at that object, chances are he's trying to grab that object, right? On the cheaper side, we also have the Samsung HMD Odyssey. These are a bit old, quite old by now, but they are quite cheap. And just to show an example, this is one of the first few Oculus devices. It does not have any positional tracking at all. And it's interesting because to use it, right, you simply just look around, standing in space, and using the clicker that you see there, you have to move your head and use your head sort of as a mouse. So while it works, right, it didn't really make much of a impact on the market. But since then, the mobile VR ecosystem has evolved. This is the first generation Oculus Quest, which has now been superseded by the Quest 2. And this is interesting because it's fully self-contained. You do not have to actually connect this to a PC, although you can. And on its own, you can just put it on straight away, start using and playing games on it. The problem, of course, is that you do not get as much power, and so you won't see generally you won't see AAA level kind of graphics with these kind of devices, but it does have its own use case. Generally, people like to use this for VR fitness kind of games. Right. This is also what Oculus used to make. It's a PC only version of the Quest with a couple of differences. Yeah, and if you want the cream of the crop, right, the best VR headset you can get out there currently, this is the Valve Index. What's unique about this is that it has the highest refresh rate of all of the other devices and the largest field of view. So largest field of view in terms of the more conventional headsets. There's another one that I'll mention a bit further, but the other cool thing about this, right, is that these controllers have full finger tracking. So the controls look a bit odd, but basically you strap it across your hand and they can sort of hang there strapped to your hands, right? Because the grips themselves, right, have some sort of sensors, right, you can actually track all your 5 fingers. So if for example I do this, right, in game my character actually do this, and you can do a lot of very interesting things. Like for example, there are games where you can, let's say, take a cup as an example, right, and just sort of twirl it because it's that accurate. Why don't they use glove for tactile stimulation too? Those exist, however, they are quite expensive. You should be able to find some Kickstarter projects out there trying to implement this, but it's not widely available. So in general, most games do not have developer support for it, but it is something that people are exploring. It's just that currently the cost and developer support doesn't really make sense for most people to get it. But if you're building a custom application, sure. Right. There are patents as well. I think Microsoft has a patent for a controller that adapts based on the object that you're holding. So it would transform itself. It would extrude out and like shrink based on the object you're holding. All right. So these are some of the couple other headsets in the market. The top left is the Pimax, which actually supports a much wider field of view, as you can see from how wide it is. Right, but generally they're not as popular and they are extremely expensive. On the right of that, you see PSVR 2, which is still very new. It got recently announced, and all of these are slowly improving the ecosystem, and we'll see how things go. All right, as for augmented reality, I'm not going to dive into too much for augmented reality glasses and headsets, but in general, most of them, right, are just simply sticking an Android tablet or UI, right, in front of your face. So Google Glass is something that I think most of you guys have heard of, but may have completely forgotten about it as it sort of just disappears. But this essentially what they did is that instead of completely throwing the product away like Google tends to usually do, they actually pivoted to the enterprise sector. So they're using it to like show additional information for people working in logistics and etc. Epson also has one very similar in concept, except this one gives you like a full Android tablet in front of you. Kind of awkward to use, to be honest, but it does have use cases. You can show helpful documents while you're working on something else, right? And you also have the RealWear, very similar concept, but you can see it's less intrusive if you're wearing glasses and so on. All right, so this is something that's new, relatively new. Before that, you have AR and mobile phone that isn't too interesting, but with the advent of ARKit and AR Core, right, you can see AR being able to do a lot of things that MR can. So with ARKit and AR Core, the system is actually your Android or iOS phone, right, can actually build a 3D map of their surroundings, and based on that, right, it can do things that MR can do as well. Except of course you do not have the much more intuitive interaction that MR has, which I'll go into a bit. The best thing about this is that almost everyone nowadays who has a decently recent phone has access to this. So if you want to create an application that has a wide reach, ARKit and AR Core is one way you can look at. Right, now on to mixed reality. Mixed reality is probably the most futuristic one out of all those today. And the cool things about this is that almost all of them have some form of hand tracking. And the best part is that you're able to see other users. So while this is currently too expensive for the average consumer, right? A lot of companies are employing this for training, to facilitate production and so on, right? Some of these devices include the Magic Leap 1, right? Which is quite interesting. It has this goggles they put on your head, and the compute is put out to a separate device that you see called the Light Pack. While it does have hand tracking, right? It relies a lot on this controller, which you can see it looks sort of like a miniaturized version of the VR controllers you see before. And while they do not offer the same quality of tracking, it is pretty good, right? For point and click and sort of those kind of interactions. That, however, has been in a way superseded by the Magic Leap 2, right? With which we do not know that much about it. It's only been recently announced, but they do claim that they have a much wider field of view. So I do have a slide later on that goes into the differences in the field of view, and we'll take a look at that in a little bit. But one thing you'll notice, right, and I want you to sort of like remember how the design of the Magic Leap looks, right, compared to the HoloLens. So for those who wear glasses, you realize that the Magic Leap's design is actually quite problematic. Because it's a set of goggles, you can't actually put it on properly because your glasses are going to get in the way. And considering that these devices tend to be more targeted as enterprise, right, where devices can be shared, this becomes a bit of a problem, which is why in general, what we've seen is that most companies try to get the HoloLens instead. And this device you see here is the HoloLens 2. It was released in 2019 on paper, but most of the devices were fully released in 2020. And this is the second version of the HoloLens. So in 3 years, they went from this to that, and you can see that it's definitely much more refined. And we'll take a look at the kind of interactions that you can expect on a device like this. Sure, hope the video is smooth. Okay, the video is not smooth at all, I think. All right, I'll just pause it here. But you'll see that with the HoloLens 2, right, because there's full hand tracking, you can actually press virtual objects, right, and they'll react as you would expect. It's a bit hard to see here because the video is kind of jittery and all, right, on the stream. But you see that you'll be able to, you essentially can grab objects, use them to stretch them as you would as if like it's like a interaction on a touchscreen, except this is in 3D. And in general, it makes grabbing objects and interacting objects much more natural. All right. I will link this video later on so that you guys can see much clearer what you can do. All right. So this also has eye tracking, and you can get features like eye tracking, auto scrolling. You can have attention tracking to help you with analytics with your applications, especially when you're doing play testing or user testing with the application for UX purposes. And the ability for you to track your hands with such accuracy, right, allows you to do a lot of things. You could do things like, for example, hold an object by maybe hang it on your finger and do gesture recognition. For example, I can do this, and the device will be able to recognize and potentially do different commands with it. There's reasons why we don't actually use that. For example, like lacks discoverability, but the ability to do so, the presence of this kind of information can go a long way into building much more interesting applications. Now, to take a look at the field of view, right, you see that the specific platform has evolved quite a lot. Starting from HoloLens 1, which had this very narrow 30-degree field of view, to the Magic Leap 1, which had 50, then HoloLens with 52, and now with the Magic Leap 2, right, they're advertising a relatively huge field of view of 70. Again, this is very narrow compared to human vision, which goes up to around 180. And even with VR headsets, this is still quite narrow. VR headsets tend to have anywhere from 100 to 130 degrees. So it's still very limited, but as the technology improves, this will become less and less of a problem. Right. So for XR, how are companies mostly using this? One is engineering, right? A lot of engineering involves 3D objects, and being able to visualize these kind of objects, right, helps a lot. I understand I'm covering a lot of these industrial use cases. Games are still more or less what you see with VR, but with AR and XR, the industry is still growing to learn what's possible, especially with MR being right now way too expensive. Although hopefully in the not too far future, right? There are cheaper headsets coming out. There's rumors of an Apple-based headset which might bring it to consumers and popularize it more on the consumer side of things. Although it's hard to say how successful it will be right now. Right. On the other end, you also have architecture and design. It allows architects to be able to visualize their 3D models right in front of them without having to construct it. They're able to deliver and present this to their stakeholders in a much more intuitive way. And for a more practical use case, right, there are companies that employ this together with construction. So they are able to isolate a part of the design in the 3D design model and bring it into the actual construction place. And through this, they are able to detect things like, oh, okay, they're able to overlay the 3D model on top of the physical space. So they're able to see like, hey, does this constructed room look exactly like how the designer intended it to be? Is everything in order? Are alignments accurate? One of the cool things about this is that there was a use case, I can't remember by what company, but they were able to actually detect that, hey, one of our designs, right, the specific, I think it was pipe or some sort wouldn't fit, and they were able to resolve these issues, right, before the pipe actually went to construction by using a 3D model of it overlaid on the physical space. The other is medical. I think recently, a couple months back, there was also a news article on NUH using this to demonstrate how it may be possible in surgeries. Japan has actually worked on this about 1+ year back, and it's very useful for them because currently, when you're doing an operation, right, you need to keep your hands clean, so you can't interact with panels and so on. You need assistance. But since with, for example, the HoloLens, right, you're touching stuff in midair, you're not actually touching anything to dirty your hands. The surgeon himself can intuitively get access to whatever data that he needs very easily. And as some of you guys may have seen here and there, XR is still very, very novel. You might see this kind of very interesting showcases at certain exhibitions and so on. Right, manufacturing for guidance. Right, not too much to say there. Being able to have a guide in front of you along with diagrams on the object you're operating with, right, is so much more helpful than, for example, referring to a book, right? If you guys have worked with and tried to assemble IKEA furniture before, you should know what I'm talking about. Okay, so how would we go about building these kind of applications? So as a developer, there are quite a few platforms you can use. The most common is Unity or Unreal. And generally for most of our a lot of developers are currently using Unity because of its ability to its current ability to support a wide range of VR, AR, and XR platforms. That Unreal is still very new to exploring. Although you can see for Unreal, they are quite big in the VR space. Although you'll see this a lot more limited for more mobile kind of VR use cases. If you are building your own engine, you can feel free to use OpenXR, which provides platform independent bindings to your XR controllers, your XR display, and so on. Right. There are also all libraries to help you build these faster. Even if, let's say, you're using Unity or Unreal, a lot of things may not be present. For example, some sort of prefabs or objects that allow you to control and drag objects here and there easily. A lot of this is not built in to Unity or Unreal, because simply what Unity and Unreal gives you is that, okay, I'm going to tell you that you have a controller at this position. You're able to check if the triggers are being pressed. That's pretty much it. There's not a lot of code already pre-written for you to use to, hey, I attach this component to this object, immediately I can start interacting with it, let my user grab it without having to write any code. Things like VRTK and MRTK, these frameworks help make those things easier. Although in recent years, Unity is pushing out their XR interaction toolkit that brings in a lot of these features. So again, the industry is moving. It's still a relatively new industry. A lot of things are changing and new things are being introduced. Last thing is on this list, right, is Azure Spatial Anchors. And if you recall, I mentioned earlier that I was able to build a framework that allows applications to work across VR, AR, and MR. And when you're building multiplayer applications like this, right, one of the key ideas is, how do I make sure that if, let's say, these users are in the same physical space, if I put a 3D model in front of them, how can I make it so that they are working and interacting that same object at the exact same position? Because each object will have its own coordinate system based on where the user started the application, right? So Azure Spatial Anchors is a Microsoft Azure service and SDK that allows you to essentially share a location across multiple devices in the same space. So by using this, right, I can very easily say, okay, user A using, say, an Android phone with ARKit enabled has placed an object on this table. And once the object has been registered to the Azure Spatial Anchor service, right, anyone else who connects to the same server with the same application, even if they're on different devices, will be able to see that same object on that exact same table. So this is very, very helpful because it takes away a lot of the manual work that we need to do to align objects, right? Previously, what we had to do was, okay, we'll have a QR code here that the devices will recognize. And once you see the QR code, we'll use that as like the shared anchor and everything will be placed relative to it. With this, a lot of it is just automated. It uses each device's own mapping capabilities in order to do the anchoring. Right. And to end off, if anyone's interested with developing for the mixed reality toolkit and so on, right? And keep in mind, even though it's called a mixed reality toolkit, it supports more than just mixed reality. It works for VR, it works for MR and AR, and it works across multiple devices, right? So you can take a look at this. It's actively being developed, and there's a whole host of tutorials and more. If you would like more help, there's also a Slack server that's open to pretty much everyone, right? Just need to click on that and register. And there's a big community of people working in VR, AR, and MR who are quite willing to help out. Microsoft's own team is also there. So if you have any questions on the mixed reality toolkit, etc., they're also available to answer. Right. So that's it for my presentation. Right. Yeah, feel free to contact me at any of these on Telegram, Discord, or via my email. And yeah, yes. Does anyone have any questions so far?
Hi, Kawai. This is Chong Meng here. Maybe I'll just start with one question. I'm just curious, since Facebook is changed their name to Meta, but I realize they don't really have as much like products in the VR MR space, because just now the links you gave were all Microsoft. So like, do you think that there will be like more resources from them in the future?
Generally, I am not too familiar with Facebook's development tools. In general, because most of their SDK are very specific to their own platform. So if you're using their tooling, right, it makes it easier to develop only on their platform. And in general, when you're building XR applications, right, you already have a very small audience compared to if, let's say, you're building a PC 2D game, right? So generally, you want to use toolkits that are more cross-platform, which is why generally for, at least for me, because my development was mostly centered on the HoloLens, so it's Microsoft based, but the creation of the mixed reality toolkit as a cross-platform framework has made it very easy for us to deploy all of our applications, from Valve's VR headset to HTC's VR headset to Oculus VR headset, to mobile devices and so on. So you can take a look at their documentation. I do believe that they have very interesting design guidelines, although it's been a while since I've taken a look at them. But yeah, in terms of technical implementation, I would suggest using cross-platform frameworks instead. You'll save yourself a lot of time, and there's really no need to develop for, specifically use these tools that only lock you down to one ecosystem.
Understand. It's like Unity offers cross-platform, so just use Unity with some tools and you can get okay, understand. Thank you.
I mean, and it's entirely possible that you may have needs that you need to specifically develop only for one platform. That's fine also, but just weigh your options and all that. In general, though, cross platforms is more or less the way to go. Yeah.
How about the rest? Do you have any questions? I mean, we had a series of VR talks so far, VR XR, sorry, VR MR and AR talks. So is there anything that you'll like to find out, or any of you are interested to work? You can ask now, because you look at the last line there, is they're hiring.
Yes, we are hiring. So if you're interested, feel free to hit me up, then I'll direct you to the right channel.
On that point, right? If you want to reach out to I guess a larger audience, do you mind like PMing like one of the excos, like a job description, and we can post it on the channel?
Sure, I'll talk to my HR team.
Good. Yeah, I guess if like no one else has any questions, I think we can officially close the session.
Yep.
Or yeah, if that's the case, thank you, Kawe, for coming down for this wonderful talk.
No problem.
And,
happy to share.
Yep, and thanks all y'all for coming to